So an atom is a nucleus of protons and neutrons surrounded by a cloud of electrons. That's an atom. But what is an element? An element is really just atoms that have the same number of protons. That's it. So it's just like the number of protons that something has defines it as an element. So let's use an example to look at this lithium, like we used before. We said it had 3 protons. So that really means that any atom that has 3 protons in it only is a lithium atom as well. And so lots of lithium atoms, or even just one, together, or 2 atoms, like it doesn't really matter the quantity, that is the element lithium. And so you could hold a chunk of it. It's like a metal. It's pretty soft. You could hold a little chunk and you'd be like, all that is a whole bunch of atoms that each have 3 protons and nothing else. So you'll see that, especially when we look more at the periodic table, usually it has a box for each element, and the box for lithium would have its element symbol, but it would have a whole number as well. That whole number is the atomic number. And it's really just represents the number of protons. So the whole number in the periodic table associated with that element symbol is just telling you the number of protons it has, which is super useful. So what's interesting about proton or atoms or elements, so they're made up of charged particles and non-charged particles, the neutrons, protons, and electrons. But if it's an element, it will not have a charge overall. And really, that's just a way of saying that in an element, the number of protons is equal to the number of electrons, and that equals is important. So for lithium, it has 3 protons. So it has to have It has to have 3 electrons to be the element. Now, that doesn't mean that it necessarily will, like an atom of lithium may be an ion that actually has an imbalance between the two. Or, so here we go. So if the actual element is defined by those protons, the number of electrons, something will be in its elemental form. That's another way we say that. Let's write that down. Or but if they have the same number, if you had a couple atoms and they had different numbers of protons, they would be 2 different elements. Maybe one's lithium, maybe one's sodium. But if they have the same number of protons, they're the same element, but they might have different numbers of electrons. In that case, we would call them ions. They would be different ions of the same element. Let's not call that atom, element. So an example of this would be the ion that lithium is most likely to form. So lithium is found as a salt, and it's really common to see it where it has 3 protons and 2 electrons. So if I have 3 things with a +1 charge and 2 things with a -1 charge, there's an imbalance between the 2. So 2 of these protons and 2 electrons will kind of cancel each other's charges out, right? They'll balance, leaving kind of 1 extra +1 charge in the overall atom. And so this lithium is said to be an ion in this situation when there's an imbalance. And so this is actually, we write it as lithium plus. It means that it's a +1 ion. Anything that is a positive ion, we call a cation. So to kind of counterbalance that, let's look at something that might be negative, like chlorine, the element. is typically chlorine negative. So it is a -1 ion. And because it has a negative charge, we actually call it an anion. So elements can have different numbers of electrons, and then they become ions, either a cation or an anion. And we stop calling them elements at that point. We just call them ions. But they're still fundamentally lithium, right? One's lithium, the element, one's lithium, the ion of the element. But atoms can also have, if you have two atoms with the same number of protons, they can also have different numbers of neutrons. And when the number of neutrons are different, the overall charge doesn't change. So we can still think of it as an element. But those two atoms would be isotopes of one another. An isotope just means that there is the same protons, but different numbers of neutrons. Usually one isotope has one or two more neutrons than the other. And so that means that they're actually going to weigh different amounts, right? So the thing that changes about that isn't the overall charge, but the overall mass, because neutrons and protons have significant enough mass that if we increase the number of neutrons by 2, we would be changing how much the atom weighs. So an example of this, we had before that lithium had 3 protons and 3 neutrons. We would represent that with an isotope symbol. And so an isotope symbol will look like isotope symbol. The chemical symbol for lithium. And we would put the number of protons at the bottom and the sum of the protons and the neutrons on the top. So this 6 right here is this 3 plus 3, and it represents what we call the mass number, which is really just related to like what is the number of protons and neutrons. It's always a whole number. And so this together would give you information about the number of protons and neutrons and the number of protons. A lot of times you'll see it without the atomic number, the number of protons at the bottom. Because you can get that information just by knowing the chemical symbol. You could look at a periodic table and be like, oh yeah, 3. There's three protons for lithium. So a different isotope would be one that was, let's do 5. So this isotope symbol, so this is a different isotope. This one would have 3 protons still because it's lithium and only 2 neutrons. The 3 plus the 2 equals 5. That's our mass number right here. So you sometimes see these isotope symbols written, especially if we're looking at things like nuclear chemistry or radiochemistry, which will not be the focus of this class, but just sharing like what differences in neutrons, electrons, and protons would mean for an atom.